I'm Ian Chilton from LONAP. I'm not a public speaker, I'm an engineer, so this won't be the slickest presentation of the day, but hopefully you find something useful. I gave this talk a few months ago at DevOps Days, and it was a talk about network automation, but with an introduction to LONAP at the beginning. I was asked to give it here partly because we've not spoken at UKNOF for years, so it's kind of a useful update on what we've been doing at LONAP, as well as kind of looking at how we've implemented network automation. Slight detour. A few months ago I was talked into this, so I was a guest on a podcast, and we talked about my career, what we do at LONAP, network automation, our use of netbox. Sorry to the Notabot guys. Might be interested if you want to check that out. So LONAP, we're a member-owned, not-for-profit, neutral internet exchange point. We've been around for quite a few years. We have 8 points of presence across 7 of the major London data centres. We have around 250 members, around 350 connected ports. We peak at just over 1 terabit per second of traffic, which is about 130 million packets per second. We do all that with 4 full-time staff, plus a board of non-executive directors. And many of our members, some of them are in this room, many of them you'll be aware of. These are our points of presence. So like I say, we're in 7 data centres. Many of these are campuses, so you can get cross-connects from other buildings and still connect into our POPs. This is what a few of our POPs look like, so we're not going to win any cable design awards or neatness awards. We try and keep it neat practically, so we can get devices in and out should they fail. We leave space next to them so we can put a replacement in, we can move cables across, and we try and keep it reasonably tidy, without velcroing everything up so tight that it's a nightmare to then add stuff, take stuff away. We run a very portrait network, so if you tilt your head, then you might derive that we use Arista hardware on the production network. We're in a leaf spine topology. We use VXLAN with Flood and Learn. The sites have different boxes depending on the connection requirements in those sites. We use 7280 SRs, which have SFP plus slots where we can do BiDIs, 1 gigs, that kind of thing. We use 7280 QRs, which are 40 gig boxes, but we break them out into 4 times 10, so we can do very dense 10 gig and patch it neatly. And then just in the past couple of years, we've been adding 7280 CR3s, which are big 100 gig boxes, because we've seen a massive surge in people connecting at 100 gig. And earlier this year, we upgraded our spines in Telehouse to 400 gig boxes, so we now have 400 gig spines, and we're doing a lot of 400 gig links in the core as well. And we also run an out-of-band management network that connects to all of the admin ports on switches, on terminal servers, that kind of thing. We have servers connected in. We run a lot of our internal VLANs over that network. So that runs over the same fiber on different wavelengths to the production network, but it obviously doesn't touch any of the production hardware. My job title is DevOps engineer. That obviously has a number of different definitions. I like to think of it as I do development and operations. As with any small company, I kind of do lots of different things and get to stick my nose into lots of different things, so quite a list there. So on to network automation. So when I started, the network was almost completely configured manually. There was a script for setting up inter-site links because it requires interface config and BGP config. So there was a script for doing that, but the rest of the config was all managed manually. So there was a config template. When we got a new device, we'd take the template, we'd paste it in, and then we'd configure each interface manually, often copy and pasting from another interface that was done before, tweaking it, and that was all, like I say, manually managed. I implemented network automation using SaltStack with Napalm to talk to the devices. And we obviously take data from quite a few sources, the main one being IXP Manager, which is our portal, it's our CRM, it's our membership information. That tells us, what members we've got, what ports, where those ports are, what speed those ports should be, etc., etc. We then take secrets from Vault. We take static configuration from a Git repository. We take templates in Ginger 2. And then, like I say, we use Napalm to push that to devices. We also have kind of some other monitoring around that, which I've tried to show there. So yeah, just an interesting point on. Obviously, I did this. I implemented this on a live network. So this network's, like I say, peaking at a terabit per second. That's doing live internet traffic 24/7. So there's not really a good time to apply any of this stuff. We had to apply it while the network was running, and just do it very, very carefully. Obviously, the alternative to that is to implement network automation on a network as you build it. Almost the interesting thing about what I did was it was a lot of work to generate the same config that was already in the boxes, but then you've got a good reference point. You can reconcile that, and obviously with so many years of configuring these networks manually, you kind of get all these little inconsistencies that creep in, like this box over here isn't quite the same as this box over here. Different templates have been used over the time. So then there was a whole list of stuff to reconcile, which we had to do very carefully. Is this something that needs fixing on the box, on the live config, or actually is this something we haven't come across yet and we need to build into the templates and modify the templates to take into account that use case? So there was a big kind of reconciliation process as we rolled this out from box to box. So just a kind of whistle-stop tour of what we did. So like I say, we used SaltStack. I ended up building all of the logic into the templates, and this kind of becomes interesting a bit later on in the talk. So just a quick few bits on some kind of key data points, if you like. So SaltStack has a concept of grains. That's like facts in other systems. So we can query a device and we can get like lots of different information, like its IP addresses, its serial numbers, its operating system, and then the templates can make decisions based on those things. We also have Pillar, which is static configuration that we can provide. So things like NTP servers, DNS servers, users, SFlow data, or SFlow configuration. So we can actually have a repository with all that data in that we feed into SaltStack, and it can use it, and that can also affect the configuration that's generated. The other cool thing about the Pillar is it's merged. So we can have, I kind of built this tier system of, we can have global config that applies to everything. We can have OS-specific config. We can have site-specific config, role-specific, device-specific, and it gets merged and overridden as you go along to come out with a config for that device. So the merging thing is really, really useful to do that. There's also a concept of salt mine, and that's where a device can effectively push information about itself back into SaltStack. So then we can use that on different devices to generate their config. So for instance, where switches link together, we need to know information about the other side that we're connected to. So for instance, it's ASN, it's loopback IP to create BGP sessions. So that's all pushed into the salt mine, and then a device can query the salt mine to find information about a device it's connected to. These are just kind of some examples of little snippets of templates. So you can kind of see, you'll recognize this as Cisco-y or Arista config that then has these templated elements in. One thing I meant to mention earlier was the target audience or users, if you like, of this system is myself and my couple of colleagues who are network engineers. So we're not trying to abstract away any of the complexity by doing this automation. We're just trying to make sure things are easily applicable, that they're consistent, that we can stand in the middle of the data center and run this tool without them to think about config and what am I doing, is this dangerous, am I going to break things. We can take away the human error element and make things really quick and easy to run. We're not trying to kind of hide away the config, to give it to a user that doesn't understand the network. There's also, two ways you can apply this config. So we can merge it or we can replace it. If we replace it, we replace the entire device config with our config that we're generating. Obviously, that's good because that ensures that the whole device is configured from the automation. That means someone else can't go onto the box and apply config, or if they do, it kind of shows that something is different. If we merge, then obviously that's the easiest way to get started because we can just start doing bits of it and automating bits of the config. But then it does mean there can be config on these devices that you haven't put there, that other people have dipped in and put there. When you're merging, there is a quite useful way. You can actually do in this case, no NTP, or you can default interfaces. That's not applied in like a procedural manner where that will happen on the switch. What happens is when you give this new config to the switch, it looks at the differences and basically works out a diff, as you'll see in a minute, and only applies the changes. So we can actually default an interface, then give it an interface config, and it will only apply what's actually changed. And that's really useful. This is internally how Napalm applies these configuration changes. So I won't kind of dig too deeply into this, but basically it creates a config session, and it does what I just said. It works out the diff of the changes, and then we can either throw that away or we can commit it. Except this happens inside Napalm. Sorry, we don't manually do this. The other thing is we don't actually run this automation automatically. We want to be in control over when it's run and kind of make sure it's doing the right thing. So I kind of made this wrapper script called run salt. So basically you can see the flow there. So we run the script. It takes all of the data from all of the sources. It generates the config. It goes to the device and says, here's this config. It gives us a diff back. We see that diff on the screen, and then we can say, yes, apply that, or don't apply that. Something looks wrong here. We won't apply that. And then also we get a daily email that says, these are the changes on the network that if I ran the automation, it would apply, i.e., you've made some changes somewhere and you've not ran the automation, so these things are outstanding. So that's quite useful. Obviously, that's also a daily test to make sure this thing is going to work when we try and use it. Everything's still talking to all the devices. Nothing's gone funny in there somewhere. So that could be the end of the talk. But then I started to look at this again, and I mentioned earlier all of the logic ended up being developed into the templates. So actually SaltStack was doing very little. It was providing those data points that I mentioned earlier, like the grains, the pillars, the salt mine, but it was effectively just parsing these templates using that data and coming out with a config, applying it to a device. So that's when I start to think, do we actually need SaltStack? SaltStack, it worked great for a couple of years, but it's a big code base. It's a big code base. It's an open source product that's maintained by other people. So any kind of breakage in that system, our automation's then broken. We've got to start digging into it or going back to older versions of it, raising issues or digging into the code ourselves. We're only using a very small part of it. The other thing is we've got to run these minion processes per device. So we've got a machine sat there with all of these processes, one talking to every device, and also the templates and any errors can be difficult to debug. If something goes wrong, you kind of get an obscure error back, and you're trying to poke into exactly what the problem is. So that's when I wrote our own tool to replace SaltStack. So we take very similar templates, but then it's our code that's then parsing them and applying them to the device. It has minimal dependencies. Obviously, it requires the data sources, but it's faster, more flexible. We can design it exactly how we want it to work, and we can also extend the scope of it so it can do other things rather than just things like applying config to devices. So after many commits on the first project, I basically started again. Like I say, I took the templates I'd developed using SaltStack, changed them very slightly, to reflect the data that I made available from the scripts that I wrote, basically. And then just a few kind of almost design decisions or things I was thinking about when I was thinking about this tool. Obviously, if the tool breaks, that's really frustrating, particularly if you're stood in the data center and it's loud and noisy and hot, or you're in the middle of a maintenance, you're under pressure to do something under a maintenance window, you're trying to concentrate on something else, you run the tool and it doesn't work. That's really frustrating, really annoying. But the primary concern here is that we don't break the network. The primary concern is that we generate the correct config and we don't apply wrong config to the network. So actually a design decision I made was it's better to fail than to generate incorrect config. So say one of the data sources isn't available, rather than generate half a config because we haven't got all of the data, bail out and we can fix that problem and run it again. At all costs, we must not generate wrong config and apply it to the network. I also want to reduce dependencies. Again, we don't want the tool to break. We want it to depend on as little as possible. And one of the things I did there was where we were talking to other systems, rather than that happening at execution time, I'd pre-cached the data from these systems. So I'd go to IXP Manager or Netbox or any of these other things. I'd pull the data, I'd store it locally, and then we only need to update that data. But if that data source isn't available, I can run the tool using the last data we cached. So that was just a design decision. Obviously, we do need to think about the race condition when you commit a configuration. So I showed you before the kind of workflow. So it goes off, it works out the config, it sends it to the switch, we get the diff back, and then it says, here's the diff of what I'm about to change. Do you want to go ahead, yes or no? Obviously, something could have changed in the meantime. So we want to make sure that we're going to commit the config that we've seen on the screen, not how it might be calculated if we recalculated the config now. You already mentioned about caching the files. And obviously we want to keep good logs and history, so if anything does go wrong, we can dig back and see exactly what happened there. I've got a point here. Just beware of vendor bugs. Obviously, like I say, we use Arista. We find that very good. We have very few problems. But, they write software like the rest of us. There can be bugs in there. So you can, for instance, we have seen things where you can apply a perfectly valid piece of config, but you do it in such a way or in such an order that then that causes a problem or a bug. So obviously just be careful of that. Just because you generate incorrect config doesn't mean it's all going to work perfectly. So then just a quick introduction to the tool. So you can kind of see here the command line. The basic thing is we want to run this tool. We want to run it against a device or a number of devices, which we call targets. We want to run an action, and then we might have a number of parameters. So just looking at targets, so we can run it against a single device. We can run it against multiple devices. We can use wildcards to pull out devices. We can run it on things like only run it on edge boxes, don't run it on spines. We want to exclude some things, or we want to exclude with a wildcard. So we can run the tool once, but target it against a custom list of devices. When we run it against multiple devices, it also uses threads, so all this happens concurrently. It doesn't talk to one and then talk to the other. It all happens concurrently and then comes back and gives you the results. We can pull facts from the device if we want to know them, and obviously we can build this into scripts as well. We wouldn't normally, on the command line, give it config. We'd normally have it parse the templates, but just, again, to give you an illustration of the flow. So it works very similar to the salt stacker that I showed you before. So we can run it, we can give it config. This kind of shows the concurrency. So there's one device there that it failed to connect to, and then others that came back with no changes. So it kind of lists ones with changes, ones with no changes, ones with errors. It gives us the diff, and then we can say, yes, go ahead and apply that. We also use Oxidized for backups. So when we make a change to the device, Oxidized is periodically polling those devices. We then get a diff of those changes that we've made to the config. Those are sent to a Slack channel so we can all see them. So one thing I did with this tool is this tool kind of prods Oxidized and says, I've just changed the config in this device, you should go look at it again. So we get an almost instant feedback loop. We run the tool, And if you flick over to Slack, then you've got a diff there of the change you've made. And again, everyone else can see this change in almost real time. We can, like I said, the previous example was loading some config from the command line. Obviously, we can load config templates. We can also print the templates out to see what we're generating, so we can, we can test that or we can debug it. Templates can include other templates. Whenever we do member affecting maintenance, I think the fonts are a bit rubbish here. We use BGP session culling, which a number of people, including Will, developed a number of years ago. So we can actually, when we're doing maintenance, if we have to interrupt member parts, for instance, we're upgrading the software on a switch, we want to reboot it, or we need to repatch something, obviously we'll have a window to do this, we'll advise them in advance, but then we can cleanly and nicely take away the traffic from the port by applying an ACL, which kills off it allows all of the traffic except the BGP sessions. That causes the BGP session to drop, which causes the traffic to drop from the port, and obviously starts routing through their other peering, other transit providers. So we can kind of cleanly take away the traffic, do our maintenance, put it back. Members, it's not like in the old days where members had to start shutting their BGP sessions off. Otherwise, when we pulled the fibre out, the traffic starts dropping for a few seconds. We can do all that with this tool. So we can, like I say, if we're going to upgrade the software on a switch, we can run this tool in maintenance mode against a switch. That applies all of the session culling, so we don't have to do that manually. We can, like I say, one of the aims when I developed the tool was to easily be able to debug this, debug the templates, debug what data it's using. So again, you can kind of spit out things like what's the running config on the device, what data are we using to put through these templates to generate them. And then the ideal with this tool is that we can expand its scope. So rather than just generating and applying config, we can do other things. For instance, controlling links, removing traffic from links, depreffing them. We can look up members and kind of see what traffic they're doing, or stats on the port, all of those kind of things. Ideally, you shouldn't need to log into a switch, because you should be able to run this tool and it gives you the answers you need, rather than having to log into switches all the time. That's it. Any questions?
It's me again. It's really good and really useful, because I'm sort of just looking at network automation or config automation myself. You say you sort of moved away from Salt Stack into building it yourself. Did you literally sort of integrate in with an SSH library or something and do the whole lot yourself, or were you sort of building on a framework that you found that did some of what you wanted?
I literally wrote the code myself. It uses Napalm to talk to the device, so you don't need to worry about any of that. You basically just include Napalm and give it a config, and it does that whole, what's the diff and commit it kind of thing. But other than that, it's then just our code. Like I say, that the idea was minimal dependencies, so you're not reliant on this other stuff. It's as simple as possible, if you like. So
apart from Napalm and Ginger 2, you pretty much do
and
the rest yourself.
Python libraries, that standard kind of stuff. But yeah.
Okay, thanks.
Hello, thank you so much for a wonderful talk. I'm Poonam, I'm lecturer in University of York, and my question is regarding the salt miner. I think, do you do that, your ASL resolution, like conflict resolution at that point, or you do separately, or do you have any ASL resolutions? So if there are two conflict rules when you're updating, you said def calculates that one.
Yep.
But if there is a totally different kind of there's a conflict of those rules, how you resolve which one to pick it?
The salt mine is just how one device knows about other devices on the network. So we've got configuration to say this device is connected to this device. Obviously, when you're setting up this device, you need to know some bits about this other devices. So the salt mine just allows you to query those, that data that the other devices have kind of advertised, if you like. In terms of conflict resolution, again, that's kind of done by the device. We generate the config based on the templates. We push that to the device, and it works out what's the difference between the current config and the config you've generated. And then, like I say, we get shown it so we can check it's doing the right thing. Does that answer your question?
So my question is, like, if there are new kind of devices like IoT devices which connects in the network, we could have a different, your configurations are quite updating very frequently on those kind of systems, and how do you handle those kind of resolutions?
Well, like I say, we don't apply this manually. We don't apply it automatically. We run it manually. So it's kind of human intervention, if you like. Okay. We're making sure that the config we want to push. Okay. Obviously, again, like I said, the audience of this is myself and a few colleagues. So we're generating a Arista config. The system's kind of geared around that network and applying the config to that network rather than starting to bring in other stuff. Does that answer the question?
Thank you so much.
Thank you.
Rob Wilton, thanks for your talk. So my question is, I think what we've done makes lots of sense. It's really interesting. Did you consider using anything like netconf Yang or anything like that for doing the configuration? And if you did consider it, what made you decide too much complexity, too much work in that direction, or were there other reasons you chose to go more towards like CLI templating route?
Yeah, I mean, like I say, the audience is myself and colleagues who understand the configuration. So that's obviously the other things mean you can make it vendor independent. So here's the BGP sessions we want to create. Here's the interface config, and then let the implementation generate the config it needs to for the device type. This way, we mainly did it this way because, like I say, we all understand that config, and almost we're engineers, and we want to see that config that's going to go in the device. So it was kind of natural to keep it displayed like that, and keep the templates like that. So we're working with the exact config, and like I say, our network is only Arista boxes, so we don't kind of have to deal with multiple vendors. If we had, say, a second LAN with different hardware, then rather than have two sets of templates, then maybe you start looking at those kind of things. Okay. But yeah, we didn't have that, so it almost made more sense to keep it native and keep it with config that everyone understands than kind of generate that behind the scenes, if you like.
Yeah. Okay. Thanks.
Thanks.
So this is a question from Chris Russell from Pulsant, who says, what data do you store in Netbox, given the other sources of truth that are employed?
Hi, Chris. We don't. Well, currently we use Netbox for our inventory management, for VLANs, for IP address management. But at the moment, we don't pull much of that into the automation. We're actually, the management LAN that I introduced earlier, that's currently Cisco and Extreme boxes, which we haven't automated. We've actually got Arista boxes on order to replace that with an Arista network, and then we will pull more stuff for that into from Netbox into the automation to automate that. Currently for the peering LAN, pretty much all of the data's in IXP Manager, so we kind of don't need what's in Netbox. That's almost at the moment for us going to data center and wanting to see what's in a rack, where's all our optics, that kind of information, what VLANs have we got, rather than needing to pull that to the automation. But the plan is to use, more data from Netbox in the automation in the future.
Okay, thank you. There's going to be quite a bit of discussion, I think, on here that you'll want to look at afterwards.
Hi, just hooking back to the last talk, does your automation include the configuration of monitoring for power consumption and looking at the sort of towards net zero aspects? And if so, have you learnt anything interesting? And if not, what do you propose to do?
Not directly. The automation, that automation obviously just generates the config for the devices. We have other scripts that query the API on these devices and pull out the power stats that the switches are giving us. We then also can monitor the PDUs that the switches are plugged into. So we tend to kind of take that monitor information out of band, if you like, from this.
Okay. All right. Thanks.
Thank you. Cool. Thank you very much.